Transformations. What do all of these graphs have in common? All of these graphs are a V-shaped graph. The one in the middle at the top here, this is considered the original graph, which we call parent functions, but I'll get into that later. Now, each one of these other graphs have some sort of transformation to it. And this is our bank of options. So the graph that has now moved to the left or right would be this one. So again, I started with that point in the middle, that point shifted to the right. One that is called a vertical compression, so it is smooshed down, would be this first one, because it is now wider. A vertical shift up or down would be this bottom one. A vertical stretch, so one that has been skinny, it's pulled up, would be this example. And then lastly, the reflection is the one that flips upside down. So these are the options that we're going to have when we talk about transformations. Parent functions are when nothing is happening. So for example, we're going to use y equals f of x as a parent function. That's just a general function notation that we're going to use. Over on this page are all of the transformations that can happen and how we write them in an equation. First, we look for we're looking for a minus sign, because if there's a plus sign, nothing is really written there. So a plus sign means nothing has changed. If there's a minus sign, that's what causes the reflection, the pointing down. Flip over the x-axis. Then we look for a number. And if that number is less than 1, it's a vertical shrink or compression. If it is bigger than 1, it is a vertical stretch. F of x is our parent function, so that doesn't mean anything with transformations. Then, if we have a number inside with the x, that's a horizontal shift. This one's tricky because it's opposite of the direction sign. So if it is minus a number, we really went to the right. If it is plus a number, we really went to the left. Then if there's a number at the very end, that's a vertical shift. And that's the same direction as the sign. So if it's plus, we move up. If it's minus, we move down. Now I know that doesn't give you much information, and if you're a little confused, stay with me, because we're going to go through examples. So I'm going to zoom in here on this first one. Okay. So this is my parent function for these examples, this U-shaped graph. And we're going to use y equals f of x as our parent graph notation. So y equals f of x. Notice nothing's in the front, nothing's in the middle, nothing's at the end. That's just our parent function. Now if we look over here at number 2, we have our parent function, which is in black, and then we have our new function, which is in red. And what transformation do you see? Well, this transformation is now flipped. And a better way to write that is we say there is a reflection over the x-axis. Reflections come from this plus or minus sign. Remember, plus means nothing has happened. Minus is the reflection. So if I'm going to write this new equation, I'm still going to have my parent function, y equals f of x, and I'm now going to put a minus sign in the front to show that reflection. Looking at that graph, nothing else happened. It didn't move left or right, it didn't move up or down. So I can close my parentheses This would be my answer. So that blue minus sign represents the reflection that just happened. Okay, let's look at another example. So again, the black graph is my parent. The green graph is the new one. So what transformation happened here? So to move from the black to the green, I went to the right, and I went right 2 spaces. So I would say right 2. So plus or minus means there's a reflection, well, really the minus. So nope, we don't need that because it's not pointing down. A means it was either stretched taller or compressed flatter. That didn't happen. So I still have y equals f of x. H tells us if we went left or right. K means up or down. So I know my transformation I went right 2. Since I went right, it's a minus sign, so minus 2. Close my parentheses. My green graph didn't go up, it didn't go down, so I don't need K. And that would be my answer. Okay, let's look at number 4. So my black graph is where I started with, that's my parent graph, and my blue graph is my new one. So what transformation did we see? So my blue graph went down 3 units. 1, 2, 3. So I have my parent graph, y equals f of x. Now, I don't need the plus or minus because there was no reflection. It didn't get stretched or it didn't get compressed, so I don't need a. Have f and x. I didn't move left or right, so I don't need h. So I'm going to close my parentheses. And k tells us up and down. We went down 3 units, so k is minus 3 since it went down. Remember, h is the only opposite one. Okay? All right, now we have 5. So again, my black graph is my original. My orange one is my new one. So for the orange one, it looks like we have flattened, right? We smushed. So this is what we call a compression. But how much did we compress by? Well, if I look at my original graph, I have a point here at 2, 4. And then I have a point on my new graph at 2, 2. So to figure out the compression, I'm going to look at the y value from my parent graph, which is 4, and then the y value of my new graph, which is 2. So how did I get from 4 to 2? I would do 4 divided by 2 equals 2. But we can't write divided by down here. So a different way would be 4 divided by 2, which also equals 2. This creates a fraction. So whenever you divide by 2, that's the same as saying multiplying by 1/2. So we would say compression by 1/2. So now when I go to write my equation, y equals f of x is my parent graph. There's no reflection, so I don't need the plus or minus. Compression is a, so that 1/2 is now going in the front. There's no left or right, so I don't have to worry about h. There's no up or down, so I don't have to worry about k. So this would be my answer. that one's a little tricky. We're going to look at number 6. So again, black graph is my original. Purple graph is my new one. So to go from the black graph to the purple graph, I got skinnier. So we stretched. Now again, we have to figure out what did we stretch by. So it looks like I have a point here at 1, 1, and then I have a point here at 1, 3. So how did I go from the parent graph of the y value of 1 to the new graph y value of 3? I multiplied by 3. So we can say this stretch occurred by 3. So filling in my equation, I have y equals, I don't need the plus or minus because there's no reflection. A, that's my stretch or compression. So 3 fills in for A. And I have my parent graph f of x. H tells me left and right, which I don't have. K tells me up and down, which I don't have. So this would be my equation. So just remember, you don't have to use all of the letters, the A, the H, and the K. Those are just the possible transformations that can occur.